One, we are going live. All right. Hello, everyone, and welcome back to Real-Time Talk with Eagle 3D Streaming. My name is Quentin Anderson. I am the host of Real-Time Talk, and today we have Ludvig Lovén on the podcast talking about...
Hey, guys.
Hey. Talking about pixel streaming digital twins. It's a very, very hot topic. There's a lot for us to explore. We've got the expert in pixel streaming digital twins with us on the show. So let me give you a little bit of background about him, and then I'll explain the format, and then we can get into a great discussion. So Ludvig was trained as a structural engineer, and he started his career doing BIM and Architectural Visualization. Then in 2015, he discovered Unreal Engine and has been interacting with it ever since. Ludvig is currently leading the software development team at WSP Digital and Information Management in Sweden. And he also, when he's not on the computer, likes to play guitar and ski and do mountain bikes. So a man of many interests. Ludvig, thank you very much for being here today. How are you doing?
Thank you. Yeah, I'm doing well.
Awesome. So if it is your first time watching our show, this is a live show, which means that, and we highly encourage for everyone to ask questions during the show. If you would like any more information about Ludvig and I are discussing. We love interaction, so please don't hesitate. Questions, big or small, to ask during the show. We love to discuss what is on your mind. And with that, let's go ahead and get started. So, Ludvig, can you just briefly give us a little bit more about your background, how you kind of started with BIM and then began to transition over to UE?
Yeah, sure. So I graduated as a structural engineer back in 2009. So then for a couple of years, I did architect work and architectural drafting and visualization. And then I got a new job doing BIM and 3D, which was kind of new at the time. And then from there, I kind of got, deeper into the CAD softwares, like started automating CAD softwares and then developing add-in applications. And then from there, instead of using CAD softwares, we started using game engines instead. Then from there, we moved on the web, into the cloud, and onto pixel streaming, kind of. So that's sort of a 10,000 meter or feet or whatever overview of the last 10 years.
So what drew you to Unreal Engine? Was there something about it that made BIM better, or how did you kind of get hooked up with Unreal Engine?
Well, I mean, any game engine is going to be better than a CAD application for real-time stuff. So we're getting into real-time stuff, and why I started with Unreal Engine originally, we did a comparison of all the game engines, and I think Unreal won out mostly because it had just been released for free, and it was better at large-scale open world stuff, which is what we were doing at the time. Yeah, and also from there on, the Epix team has been really good about investing in the enterprise sector. Yeah, they think in 2017 or something started up a dedicated enterprise team for all the different sectors, automotive and AEC and all that. So we're getting some really good support from there, and it's a great engine. Unreal Engine 5 just came out, so I'm just starting our first Unreal Engine 5 project just this week. So that's exciting.
Awesome. And can you explain a little bit more about what is AEC? How do you fit into, what is that industry, and then how do you fit in, and what are some of the projects that you're doing in AEC?
Yeah, so the acronym stands for Architecture, Engineering, and Construction. So that would encompass everything from early conceptual architectural designs and city plannings over to, detailed design, over to the actual construction process, and even further into like the asset management and like life cycle stuff. So everything relating to the built environment, really.
And when some people think of Unreal Engine, they may think of a game engine, so for video games. So how are you using the Unreal Engine for AEC projects?
In a bunch of different ways, either by creating custom applications for like one tailored use case. Because you can do stuff that you can create your own custom interface and functions and interactivity and all that for like just one niche use case. That's hard to customize in a CAD software, even if the data is there originally. And then also for really large scale stuff where you need to get tons of data, like 200 million laser scan points or gigabytes or terabytes of data at once. Because game engines are better at culling things and loading stuff in and out of memory and rendering as needed, compared to CAD softwares where everything is kind of always rendered.
And what are some examples that maybe come to your mind of how you've used it specifically? Are you loading in, huge cities for designing and planning, or are you using it for infrastructure projects, or what sort of cool applications come to mind?
We are mainly using it for infrastructure projects at the moment, like infrastructure design. Like typical case would be building a new railroad. That's a really long project geographically. So there's a lot of data. If you wanted like a topographic, like laser scan of the entire area, or you want 100 kilometers of track, or you want to drive a train in real time, or stuff like that.
Yeah. So if we stick with this example, so let's say that I'm a country and we're building a railway, and we contract WSP in order to do that. WSP would put some of the project in the game engine so that when the project is delivered to us, does it help serve as a visual aid for us to understand, okay, this is where geographically the railway is going to go through, and this is the speed. Is that one of the main uses, or?
Yeah, that specific application, we're using it in that way, just putting everything geographically in context. Like we have like height data and aerial photography data we only have projects in Sweden right now, so we have for all of Sweden loaded. So anything within Sweden fits. We can also, if we would start expanding outside Sweden, we could add in data sets from other countries or global data sets, that kind of stuff. So that's so that piece of software is like a design coordination piece of software that has like the related functionality like you might find in some of the other like commercial pieces of software, like measuring tools able to query metadata. We have all the metadata from the CAD softwares imported in, and you can turn on and off layers and But I would say the main differentiator is that we are delivering this in the cloud through pixel streaming with a full like asset pipeline in the cloud, data imported at runtime. So instead of packaging data in the Unreal application and sending a packaged application with data, we have the application running in the cloud, and then data is loaded from the cloud backend at runtime and being translated on the fly, kind of. So we can separate the application and the data.
And what are some of the decisions that led to using or going with this workflow? What was the reason, or why did your team decide to run the Unreal Engine in the cloud, not put all the data in the actual Unreal Engine application and stream it to a browser? Were there certain challenges that you were trying to overcome, or why this workflow?
Because back in the day, like 5 years ago, when we started doing like custom Unreal Engine applications, we would then need our team of visualizers and developers to take the data, prepare it by hand, import into the Unreal Engine, package it as a project, and sending the packaged exe over, and the whole process was it was taking a long time and it didn't scale very well. Now we have a scalable cloud application where the clients themselves can just drag and drop their data in without us needing to get involved. So we can easily delivering this to more projects without the man hours needed from our developers being limiting.
So if we then think about this dragging and dropping application, so instead of your team going in and building out all of this 3D data for a new project, you're giving your customers the freedom to import existing data into an existing application for their project. Is that?
Yeah. And even so, like in a typical project, the 3D data would exist. Like it's being created anyways. Like it would be done in like 5 different CAD applications for different technical disciplines. But instead of having to prepare data specifically, like by hand for texturing and converting to some Unreal formats, we automated all of that. So the same data that's in the CAD design goes into the Unreal model, kind of.
Gotcha. And if you could estimate the changes in efficiency, when we're doing all this by hand versus being able to directly import it, is it reducing a significant barrier of effort required to digitize a project like this, or what's sort of the benefit?
What's the iteration cycle is improved greatly within the project, and also we can scale it to more projects. So instead of we put together a model with all the disciplines and all the terrain by a 200 by 200 kilometer area or something, putting it together by hand and updating it every month or whatever, we can keep it continuously updated with the latest data.
Yeah, and speaking of data, if we can maybe take a step back, and one of the things that you said that really caught my mind is you're visualizing Sweden. So what does that mean? Is it sort of an approximation of Sweden in a 3D format, or is it pretty accurate? What exact are what does it mean to do that?
I mean, it's the data. We have a base set of data with topographical data and orthogonal photography, aerial photography, with a top-down projection on top of that. And then we can add the project's data on top of it. So typically for a project, you would have a laser scan, like an aerial laser scan of the area. And we can add just everything in layers, the data. But we have already prepared for all projects, the base data sets.
Got it. So we have a working 3D model, more or less, of Sweden that is a accurate representation of the topography, land layout, land mass, the lakes, everything. Is that an accurate statement, would you say?
Yeah, I mean, it is, but it's not really anything, fancy. It's the same data as you can get in a map, Like a Google map, you zoom in, you get the topographic data, you get where the lakes are and something. But we put everything together in 3D, and you can add, lots of stuff on top of that.
Sure. Yeah. It's maybe a starting point for to grow. Would you consider this? And sometimes people use the word digital twin. Would you consider this or what is a digital twin for you?
I mean, the stuff we just talked about, it's sort of a digital twin. It's not 100%, I would say. It's a design tool first and foremost, We also have other things we can talk about that's more, in line with the digital twin stuff. But, I mean, I would say a digital twin is first, it's a 3D representation of something in the real world, and then you would need some sort of data, more information on top of that represents the state of the asset at some point in time. So this can either be, already loaded in historical data, like rainfall for the last 200 years or whatever, or you can have real-time data, like right now. What sensors, if you have a road network, you can have the real-time traffic put in there. and you can put it together in layers with like what's happening right now, or I would say even simulations, like going into the future, like based on the data set that's in the model, simulating different scenarios in the future. I would say all of those fit, and probably more use cases too fit under the digital twin umbrella term thingy.
And I know you and I were talking beforehand, and we were like, well, how are we going to define digital twin? I think that is the coolest definition I've ever heard. It's 3D data, or it's 3D data combined with either existing data, data from the past, or data for the future. And that's sort of, one way to look at a digital twin. Or what do you think?
Yeah, and I mean it's a pretty new technology, so it's kind of going from being a buzzword to being an actual technology. So I'm sure other people have other definitions, and it's going to be probably a few more years before there's like a fully accepted definition that everyone can agree and that you can look up into the dictionary. But hey.
Yeah. Well, I mean, we got to start somewhere, right? It's like trying to define metaverse right now. It's everyone's kind of got an idea, but it's still forming and it'll evolve. So. So how are you using digital twins?
I mean, one thing that would be good to bring up is the actual, the digital twin stuff we've been doing with Epic. So I was on the what's it called, Unreal Engine webinar thingy talking about that a few weeks back, months. Time flies. So yeah, for those of you who don't know, we just before the end of the last year, we released a free digital twin plugin for Unreal Engine, as well as a sample project with some sample content on how to use it. So that connects Unreal Engine to Microsoft's Azure Digital Twin. So it's a project we did. It's like a joint effort between us and Microsoft and Epic. So it's free on the marketplace for you to grab. And there's also the Unreal Engine webinar that I did called Visualizing Data in Digital Twins. So that's more of a like asset management, building, owner, operator kind of scenario that shows you like how to visualize real-time sensor data in like an office context. That has some point clouds and it has some sensors for airflow and temperature that's changing. So we've shown you how the full workflow works. You can, there's a template for how you can set up your own cloud backend and start a device simulator that sends like mock devices to sends data, and then it's all visualized in Unreal. So we are in the process right now of updating that to Unreal Engine 5. I've just spent half of yesterday just trying to figure out the particle systems because there's been some changes in that, but the other team members have done their parts because they're more efficient than me apparently. So we should I think the plugin is on its way to the marketplace for Unreal Engine 5, and the sample project will be when we figure out the particle systems.
So if we want to grab the sample project for UE4, I know you said it's on the marketplace, but can you give us any pointers on like what to Google to find it, or what do you think we should put in?
Yeah, it's called ADT Link. ADT is an Azure Digital Twins. So there's two of them, ADT Link for Unreal Engine and one for the sample content. And I think I mentioned that the webinar where all this information is mentioned too is called Visualizing Data in Digital Twins. Should be on the Unreal Engine YouTube channel, I think.
Cool. So if anyone would like more information, check out the Unreal Engine YouTube channel for Ludvig's talk on visualizing data, and then also try Googling ADT Link Unreal Engine Marketplace if you'd like to look for the plugin and the sample project. Ludvig, did I get all that accurate?
Perfect.
Oh. So how's it going with UE5? What's up with the particle system?
No, they just some stuff that was sort of not really documented or packaged. Like I used some custom functions from the Niagara Advanced Examples that now has been put into a plugin called Niagara Fluid Simulation that we used to do the temperature gradient field. But that one it's still the functions have changed, so I've replaced them, but it's still experimental. So I'm just trying to figure out, can we release it now, or should we wait before the plugin becomes like officially activated in UE5? Since it's I mean, it's so early.
Mm-hmm. And with the temperature, you know what I'm picturing, and this may be with my limited experience, but if we create a digital twin and we're inputting temperature data into that digital twin model, why are we doing that? Are we trying to see if there are inefficiencies in temperature where we need to insulate more in certain areas, or what are some ideas that you could do with temperature data, do you think?
Yeah. So how we're thinking about this is it's a good way to quickly visualize, like if you have tons of sensors. The example we have has like 5 sensors. Okay, but what if you have 300 temperature sensors? So instead of looking at a list of the temperature sensors and current temperature, location, and one of the readings are off, and you have to figure out what it is. Instead, you can see it all in 3D and see that it gets colder towards this area. Why is that?
Got it.
So that kind of stuff.
Got it. So it'll give us kind of like a 3D representation of temperature in real time. And then, maybe, it looks like, this window pane or this area, is letting cool air or warm air out. And so we maybe need to modify or adjust things, something like that.
Yeah, exactly.
Cool. What other types of data would you put into a digital twin, and how would you then use that data?
That depends on the digital twin, like what the context is. This is so many. Like in a building context, you have the stuff like if you're concerned with building efficiency, like the stuff we had there. So like temperature and airflow. We also have like lights, on and off states for lights in different areas, and like desk occupancy. I think there's the sensors we have in the example, but really, anything you can visualize, you can do an abstract visualization of, and anything that makes sense to measure, because the data it's gonna be barely better than the sensor data you put in. It's just an easy way to aggregate and put it all in context with the building. Like, okay, you have a reading from a sensor, but where is the sensor? What's around it?
Yeah, and I'm sort of playing devil's advocate here, and why can't I just have Power BI report of all this data in real time? Hey, I get to see what all the sensors are telling me. The advantage of the 3D piece is being able to see it in context, would you say?
Yeah, like where is the sensor? Because that's something you can't easily see in a Power BI report. Because in a building, like you can't see that, okay, these 3 sensors are like next to each other. They're in the same room. They're in the same like XY location, but on different levels, or where is everything in relation to each other? I think that tells you a whole lot, and the more information you put in, the more it adds, I would say.
So could I also import data about, let's say I own a building, could I import data about occupancy rates? Are some of these spaces not leased versus leased? What is the occupancy over time? Is stuff like that possible?
Yeah, I mean, sure. That's not really real-time data, and I think there's already, probably systems for that. Like, I do, off the top of my head, you could put that in, but I don't feel it's something that needs to be invented. That's just my
Got it. So
take on it.
So what data do you feel is necessary and important to kind of put in?
I mean, in a building context, I mean, even if the data is there, I mean, the stuff you mentioned, it would be, I would think, on its own, probably, not that much value added. But if you put it together with all the other data from all the different sources and like look at it in the same place, So it's so hard to think of a concrete example, but what if you have the temperature data and you have the occupancy? Okay, so the tenants in this area has been changing every 2 months because no one keeps coming to the store. And why? Because there's something wrong with the air conditioning, so it's too cold in there. Or, I mean, stuff like that.
Yeah. Yeah, I mean, yeah, and there's so many different applications.
Yeah.
We got a question in from the audience.
Yeah.
They
Hit
said,
me.
when designing digital twins, how important is it to consider security risks or threats?
To the IT infrastructure, or
Yeah, I would probably maybe just take it as how you're sort of interpreting it. IT
yeah.
infrastructure or any other, yeah.
Yeah, I mean, I guess if you're sending real-time data over the internet that can be intercepted, that kind of stuff. I mean, I think I'm not really an expert in this field, but the reading I've been doing is that there's encryption in all layers, and I would think that the sensors have their own encryption, and then you need to use some reliable backend for your cloud stuff. So obviously something like Azure Digital Twins from Microsoft takes care of all that. But if there's sensitive data that's being sent from one source to another through the internet or whatever, there's always all kinds of security risks that you need to consider. And that it depends on the data. If someone hacks a temperature reading, it might not matter that much, but you need to do your own assessment of what the data is.
Got it. So it depends in part, what type of data it is and the level of risk associated with it.
Yeah, kind of a non-answer, but hey.
So going back to the browser then, how or why did you decide to pixel stream some of these digital twins, or what was the reasons behind that?
I mean, our main reason for pixel streaming anything was, delivering this to clients, most of which probably will not have computers that can run like a graphically intensive application like Unreal Engine. So even if like the performance of these cloud machines, they are probably not at the level of like if you go out and buy a top-end computer, that's going to be better. But it's also the performance is known. You have a target platform, you know what you can optimize for. Instead of having, we send out the applications to 100 different people with 100 different computers. You need to do all the research on the, min specs and all that. So we don't have to bother with that. We're doing it for one platform, and the clients don't need to download anything. I mean, if we have something with 20 gigabytes of point cloud data, they don't need to download that to their machine along with the application. Some clients might not allow you, their IT might not allow you to run like unsigned applications or custom applications. So then you would need to get approval from their IT department for every application you send. That's a scenario we have, which really slows things down. And also this is important for security as well. Since with the pixel stream, like you are not sending any data like over the internet. We are hosting all our data within like one cloud service. So the data is being streamed from the cloud backend to another part of the cloud backend instead of going over the internet. And also the flexibility and scalability of having a cloud backend with storage. You can scale up, down databases. You can spin up more database service. You can scale the VM pool that's running your Unreal Engine instances, like what Eagle is doing. So, I mean, I would think the list goes on too.
Right. Yeah, and that's a good point. I mean, we're really only sending an MP4 to people through the browser.
Exactly. Remote controlled MP4.
Yeah.
That eliminates so many problems. Of course, it creates problems too, but I think it solves more problems than it creates.
Yeah. All in good time, right? So we are coming up at the end of our half hour. Any other thoughts or things that you'd like to share before we begin signing off?
I mean, I'm looking for what's coming up in the future, like better spec cloud machines and Unreal Engine 5 being used more, and also hopefully being able to run on in containers in the cloud services. That's something, because right now, we have to wait for a full like virtual machine to spin up. So the start time is, a minute or two, worst case. But if we can run the app in a container, so the app layer is separate from the hardware, we probably could spin that up in a few seconds. So that's, I would say, almost mature.
Yeah, I know.
Mm.
Hopefully, you and I get to look back in 5 years and talk about the good old days, about spinning up spinning up virtual machines to stream. I know we're on the end of the hour. Do you mind taking one more question? It just came in. Or
Not at all. Go for it.
Right? Okay. So, are the digital twins designed as visualizers only, or real-time configurable? My question is related to using your railway project as an example.
So the railway project, it's not really any real-time data in that, since that's more design project. But we can load in whatever data sets you want, and also, I mean, theoretically, we could, since the railways design coordination tool and the digital twin project that I talked about, they are at this point different projects. But since the digital twin thingy is a plugin, we could, and we are thinking of, because we haven't found a good use case yet, just putting the plugin in the digital twin plugin in the railway tool and just start adding real-time data on like a country level, connecting to like open APIs and putting in like road and rail traffic data, weather for the country, and all the data you can get your hands on open.
Awesome. Thank you. And Ludvig, thank you so much for joining us today. If anyone has additional questions, is there a way that people can maybe reach out through LinkedIn or?
Yeah, I check my LinkedIn once every 6 months, so good luck with that.
Yeah. All right. Well, thank you everyone for joining and for your questions. It's been a pleasure speaking with you, Ludvig. Catch us for the next podcast, and I am Quentin Anderson, and this has been Real Time Talk with Eagle 3D Streaming. Thank you, Ludvig. Thank you all. We will see you next show.